Hey, thank you for joining us today to discuss trailblazing news around a unique cross-industry partnership that brings to life the very first and only demonstration of an electric car, a race car, remotely piloted by a driver located miles away from the track. Here with me to discuss the importance of this news, I'm honored to welcome Michael Resl, Sporting and Technical Director at DTM, Michael Martens, Managing Director, RIEDEL Networks, and Daniel Kohl, Director of Technical Development Motorsports at Schaeffler. Thank you for being here, gentlemen. In motorsports, the need for innovation is an acute and constant imperative to stay relevant. So let's talk about the incredible advances that power today's news. First, what are we really talking about? A remotely controlled, driverless, electric race car going at 200 kilometers an hour with the driver located 70 kilometers or 43 miles away. A pit crew at the track and an engineering team that might be in their office, all connected via a high-speed WAN network. Second, this never attempted before event is the result of the partnership across the following organizations. First, the car. The car is a very sophisticated, real-life, one built by DTM in conjunction with project leader Schaeffler, and we'll hear from them. RIEDEL Networks designed and delivered the entire communication network, powered in part by Cisco technology. That's where we come in. The remote run of this network-enabled race car will take place September 3rd to 5th. No doubt, it will usher in a new category of high-performance motorsports that is green and sustainable, safe and secure, and definitely entertaining. In order to perform this incredible feat, an always-on and ultra-responsive network is not only necessary, it's simply vital. Key attributes are high throughput, high speed, ultra-low latency that demand a flawless data transmission with carrier-grade availability of 5.9. Let's get to the question at this point. So first question, let's start with Michael Resl at DTM. Michael, what is the main purpose behind this driverless electric race car project, and why is it important to accomplish this at this point?
Oh, thanks, Chair. Let me first start with the wish for 100% carrier grade availability rather than a 99.99. Every 0.1% counts here, and yeah, we're hoping for that. The remote run is a consequent next demonstration step of our innovation roadmap in electric racing here in DTM. Our innovation and platform partner Schaeffler, thanks to Daniel, who is joining us, and we here at DTM did already build a 1,000 horsepower fully electric demonstrator car last year, which we saw at the Hockenheim finale 2020. It was impressive, and whoever says electric cars don't have a good sound should listen to this car, and we are still improving with the DTM Electric prototype. At the very same time at that event, we held our DTM eSport Championship, and the idea was born not only to bring the virtual and the real world in racing closer together, but also to enable a number of applications where remote driving helps to reduce costs or simply makes our lives easier. Road relevance is also an important topic for our participating teams and OEMs. And so we're looking into bringing elements of autonomous driving to racing in the future. One example just being that the car drives autonomously or remotely to the starting grid and meets the driver there, who then takes over and does the race. Another one would be to run the safety car remotely with the benefit of being able to place several safety cars along the track and simply remote start the one that's closest to the action, especially important for long tracks like Spa. The project spans the bridge from pure racing to electrification to e-gaming to real-world requirements, then this is why it was so important for us to run it.
That is so impressive, Michael. Hey, turning over to Michael Martens, RIEDEL Networks. You guys play a big role here, and you're a close partner of Cisco for many years. Can you describe the key technical components of this project on the communication side?
Sure. On the communication side, I can. On the car, I can't, but this is why we have Daniel here in this conference, right? Well, on one hand, we have the wide area network with Cisco Catalyst AC 8300 routers on each end of 2 MPLS fibers. That together with a Catalyst cellular gateway on both sides for additional backup via 5G. And in addition, we attached ISR 900 series routers with 4G modems for outband management of the whole setup, just to be safe. On the other hand, we have our own IP mesh radio network with 5 access points around the track and a fully redundant system with 2 modems in the remote car, whereby each modem has 2 antennas that are manufactured and customized by our sister company, PIDSO. And on the communication, we have set up, we are using our own award-winning DECT-based wireless intercom system. This is enabling the direct communication between the engineers and to the sim racer and Graz.
Awesome. Hey, was there based on some of the technologies that you're using from a WAN standpoint, any kind of aha moment actually to figure out whether or not actually a software-defined WAN technology, controller-based, would be actually useful here?
Yeah, that were 2 points. On one hand, as we have said that in the intro, high throughput, high speed, low latency has been required, and therefore we were looking for a platform with an architecture that supports all of that, and that is why we have used the C8K edge platform, which is definitely having a strong computing power with its architecture and the technology that ensures that connectivity is there even when fiber would fail, and that is where SD-WAN comes into play, because we can use here with SD-WAN an active mode. In case of failure of one fiber, the signal is not getting dropped. And in addition, the application-based routing helps us to differentiate between the steering signal and the video and intercom signals.
Excellent. That's awesome. Okay, over to Daniel at Schaeffler, who's leading this project overall. What were the key challenges to overcome in planning and executing this futuristic project in racing, Daniel, and any benefit also that you may want to talk about?
Yeah, thanks. So as Michael Resl already stated, it was clear from the beginning that we will have an innovation partnership together with DTM. And after what we have shown last year in Hockenheim with the DTM Electric demo car, we had a discussion about ideas, what could be the next step. And we pretty soon agreed that driving a car driverless into the grid or through the pit lane would be a fantastic challenge and showcase. So for us, after having this idea, the main challenge was, first of all, to set up, understand what is technically required to run a car under such conditions, and setting up a project team with experts from completely different fields like drive-by-wire technologies, networks, simulator stations, all that stuff, like creating a video stream. So we took quite some time to set up a group of experts which are now professionally working very hard on this exciting topic to get that car running. Obviously, remote controlling a vehicle is not entirely new, but what hasn't been done before is running a car at such speeds. And therefore, we have completely new challenges in terms of the latency of the entire system, in terms of the feedback we give to the driver, and as well in terms of the quality of the video stream we generate. And integrating all those systems into a car and get that system running was one hell of a job, you have to say. And the guys have been working day and night to get it done within a very, very tough time frame. But now we are confident and happy to approach the next weekend.
Wow, can't wait to see it, man. That's absolutely, fantastic. Speaking about the overall partnership, you just touched on it again, Daniel, obviously as leading this project. Michael, back to you, Michael Resl. So what was most important in choosing the partners to actually bring this to life and working together on this project?
Well, I guess the really good thing is that with our innovation partner Schaeffler, we already had a perfect starting point. So as Daniel described, it was easy for us because we worked on different projects together. And then, you start looking at your network, and then it was relatively simply. You start pulling together the team, each and every one, an absolute expert in the field and in his specific field. And it's an absolute pleasure to work with you guys. And you know, when we do our regular 6 a.m. morning briefings at the test tracks of this world and overlooking the committed faces of the core team, there's, other than being tired, of course, only one sentiment that springs in mind: being proud of what this group of people can accomplish. So really looking forward to get it done.
Awesome. Hey, just a final question for pretty much every one of you. So where do we go from here? What do you see actually I think there's a lot of potential applicability to maybe other industries, use cases, maybe others have solicited you again based on discussions that you may have. What do you see? Maybe starting with you, Daniel.
Well, obviously, from my point of view, what's really relating to motorsports is A, the way you generate feedback for a driver that's not actually physically in a car, and B, obviously, on how you extract data, live data from a car, and prepare them in a way that they can be accessed in our position from a remote driver, but later on maybe from the audience at the television or at the streaming devices. So that's for us a clear benefit from this project and a possible future application as well.
Very good. Michael Martens, on your side, communication side, any, I mean, it's like there is a lot we can apply here, maybe to other industries as well.
Yeah, potentially to the defense industry. We see some things of that in the movies, but if this is really working, we don't know. Probably this is one of the tests in life. And then for remote event productions, not only broadcasting, but many other things, we see there can be a real benefit to that.
Okay. Michael Resl, just to close this off.
Sure. Well, there's numerous applications outside of the racing world, but I always look through my racing lenses, obviously. But there could be, you know, as we discussed, the same driver can run different cars on different tracks without even the need for travel. There's a potential combination of sim racing and real-world racing in the future, perhaps. Actually, it would be interesting to see how a vehicle design can be optimized to its performance if there was no need for driver safety features. You know, a lot of weight gets out of the car. There's still safety involved for the spectators, but, you know, I'd be interested.
Awesome. Hey, thank you all for being here today. This is really a very captivating set of events, a lot of work going into it. So thanks to our audience for tuning in as well. We look forward to any questions you may have that you can ask through the website. Thank you. Bye-bye.